Welcome to episode 349. Boy, we are on the Takt production system. This is going to be part number 13. We're discussing Takt Works Because. I love this section, and we're going to give it to you tonight. Stay with us.
This is the Elevate Construction Podcast, delivering remarkable content for workers, leaders, and companies in construction wanting to take their next step. Get ready to step out of your comfort zone with Schroeder as he encourages you to do better, live a remarkable life, and expect more. Let's go.
Welcome, everybody. We're going to get right into it. I just recorded a podcast with Adam Hoots, and we were talking about the accountability scale. And it's a really great podcast. We're going to be recording more and more podcasts with other people. So let's look forward to the time when this Takt book audio is 100% complete. I think we're almost halfway done, and it's great content. I hope this is helping you in your personal work and scheduling and construction and whatever you do. So we'll go ahead and get right to it. This is the section called Takt Works Because. Takt Works Because. Production laws support the function of takt planning and takt control. We have been using takt planning and takt control for years without even knowing why. That is, until we met Marco, Janosch, Hal, and Nicholas. The work of these four recently have brought these production laws into focus. We'll provide an overview below. Little's Law. What is Little's Law? Little's Law is a theorem that determines the average number of items in a stationary queuing system based on the average waiting time of an item within a system and the average number of items arriving at the system per unit of time. To simplify this, let's use the definition in the book. This is lean. Little's Law states that the throughput time, phase duration, or project duration in construction equals the number of flow units, process units in construction, times the cycle time. That means the amount of processes in the system multiplied by the process time per unit determines the overall duration. In construction, this is only calculated in takt. It enables us to do the following: plan smaller batch sizes, limit work in process, finish as we go. In fact, the formula we will introduce later shows the number of takt wagons plus the number of takt areas minus 1. The sum of that multiplied by the takt time equals the throughput time or duration based on Little's Law. The only way to stabilize and optimize a project is to obey the production laws and not fight against them. Only takt allows this. Consider this. Does CPM allow us to calculate optimal batch sizes? No. Does CPM help us reduce work in process? No. In fact, it makes it easy to increase it with its forward and backward paths. Does CPM enable us to finish as we go? Not really. Maybe, but it definitely does not allow us to see when we need to finish in a rhythm. CPM does not obey this scientific and mathematical law, but rather ends up fighting it. Takt obeys this law in the following ways. Takt allows us to calculate optimal throughput times and use the formula. Takt allows us to reduce work in process not only by calculating ideal batch sizes, but also by putting work into a rhythm that makes work happen only when it is needed per the flow. Takt allows us to finish as we go by showing clearly and visually when we need to finish sequences, and it puts materials, information, and worker counts into a consistent rhythm so we have the capacity to do so. The law of bottlenecks. The bottleneck law has its origin in the theory of constraints created by Dr. Elihu Goldratt and published in 1984 in his book, The Goal. The law says that every system, regardless of how well it works, has at least one constraint, a bottleneck, that limits performance. This law also states that when the largest constraint is optimized or removed, the other bottlenecks will show up in the system. To apply this to construction, we need to understand that the process with the longest cycle time will increase the overall throughput time or duration. Therefore, bottlenecks must be identified, optimized, or eliminated. In the book The Bottleneck Rules by Clark Cheng, the author provides an acronym that might be easy for us to remember. FOCCUS, F-O-C-C-C-U-S. F, find the bottleneck. O, optimize it. Once you know where the bottleneck is, you can increase the process capacity and reduce cycle time. C, coordinate with other non-bottleneck work to increase the capacity of the bottleneck. C, Collaborate with other non-bottleneck work and see if those processes can help the bottleneck process. C. Curate the work needed for the bottleneck to reduce the demand on the process. U. Upgrade the resources that compose the process to increase the capacity. S. Start again finding other bottlenecks. In order to obey the second production law mentioned in Modig's book, This is Lean, we must be able to see and optimize bottlenecks. And because bottlenecks are mainly found in the cycle time of a process, we will find most bottlenecks by visualizing trade flow, not just workflow. CPM does not do this because you cannot see all three types of flow. You can barely see some parts of the workflow, but no one can easily see trade flow, and therefore no one can easily find bottlenecks in CPM, let alone optimize them. The very nature of a critical path focuses on the longest network of activities from beginning to end. Not only does this ripple through different trades, but it also ripples through different phases as well. CPM does not have the ability to identify bottlenecks because it does not isolate and make visual trade flow within phases. Takt, on the other hand, gets an A+ for this. In Takt, anyone can easily visualize workflow, trade flow, and logistical flow, and bottlenecks are easily seen and easily optimized with the standard work steps packaged within Takt wagons. Takt is the only scheduling system that obeys the law of bottlenecks. The law of the effect of variation. The law of variation is defined as the difference between an ideal and an actual situation. Variation or variability is most often encountered as a change in data, expected outcomes, or slight changes in production quality. Variation in construction usually comes from waste, unevenness, or an overburden on resources. To paraphrase Modig's book again, as variation increases, throughput times or duration increases. That means that as variation increases on our projects, then the project end date will extend. This means that we must see and prevent roadblocks and create standards and consistency. CPM again fails miserably on both counts. A CPM sequence is so chaotic it is difficult to see problems within the system. It also takes so much management capacity to manage as a schedule, there is very little time to even try doing so. And for the second point, again, CPM is so inconsistent and chaotic, typical and standard work steps are not created to baseline processes and cycle times so that roadblocks can be more easily seen. Conversely, Takt cares for both considerations. Takt takes 1/12 of the time to manage as a scheduling system so the team's main focus can be on making work ready and preventing roadblocks. Takt also creates a visual schedule where it is easy to see roadblocks. Roadblocks are found more easily when committed dates are understood by trade partners and when the flow of work is apparent to the entire team. In this way, Takt enables roadblock identification and removal. Additionally, heterogeneous and homogeneous work is packaged into Takt wagons and work packages in consistent ways, which allows the project team and trades to enter a weekly PDCA cycle with their standard work. This identifies and removes roadblocks for future instances of that type of work before it happens again. Takt is the only system that fully enables a team to see and identify roadblocks and create standard work on a rhythm. Kingman's formula. In queuing theory, a discipline within the mathematical theory of probability, Kingman's formula, also known as the VUT equation, is an approximation for the mean waiting time in a queue. It was first published by John Kingman in his 1961 paper, The Single Server Queuing in Heavy Traffic. The formula states that the waiting time in construction, it is the process duration, by area equals the cycle time of the process times the capacity utilization of the resources times the probability of variation in the process. So the time it takes for a process to move through an area is determined by how long the process takes, in addition to its capacity percentage, in addition to the variation it experiences. If a process takes 5 days, it may actually take 6.5 days by the time you calculate the capacity utilized and the amount of variation that affects it. This duration becomes the cycle time in Little's law and will affect the overall throughput time or overall duration. In construction, we learn that we must plan our process durations by area with the consideration of capacity and variation. In order to do that, we must package standard process cycles in a takt time. And you guessed it, Takt does this beautifully with Takt wagons, work packages, and standard work steps. The team can optimize processes within and optimize the system. And at this point, we will not bore you by telling you CPM gets an F grade in doing this. In fact, there is nothing in the CPM system that supports Kingman's formula on the process level. Takt is the only scheduling system that allows us to optimize process times by area and obey Kingman's formula. The first edition of this book lacked this crucial information. Many read the book initially wanting more science and math to back it up. Well, here it is. Study these production laws for yourself. We will not get faster in construction without obeying these laws. We have to stop fighting them. If we want lower cost projects with a shorter project duration, the answer is not to push, aggressively add manpower, bring all materials at once, and increase work in process. The answer is to increase flow by obeying the production laws. Takt works when? It seems appropriate at this point to set everyone up for success if you are considering takt planning and takt control. If you are not committed to the following concepts, you may consider waiting for a while or getting some help because takt only works to the fullest extent when we fully obey the production laws listed above. So first, we have to follow a rhythm. Takt planning really only works when we get the rhythm right and when we focus on that rhythm. As we have said before in this book, CPM slams everything to the left towards its early start. As builders, when we build, implement, and manage with takt, the focus is on the rhythm. The rhythm allows the design to be done just in time, material approvals and permits to be leveled, and the load of the team to be even throughout construction. Following a rhythm also reduces the likelihood of overburdening trade partners and crew resources. Flow is king, and the right rhythm enables that flow. Imagine freight cars behind the engine crashing into each other or stacked on top of each other. This is not the ideal state. The ideal state is when cars, or takt wagons, are evenly spaced one behind another in a row. If the project team, the project manager, and superintendent are not committed to holding dates and following the rhythm, material inventory levels, worker counts, variation, and costs will increase to the detriment of the project. Takt is not a push system. It is a holding system. We must hold the dates and follow the rhythm of the project to get the full effect of its usefulness. When we overburden resources or work steps, we lose our rhythm and overload the system. That is why we focus on rhythm and we see that rhythm because it is shown on one page. Takt plans, when printed, are used in a remarkable fashion when they are shown on one page. A member of the management committee at DPR Construction once intimated a plan should be easily seen within 5 to 30 seconds of walking into the office trailer or coming onto the project site. Try doing that with a CPM schedule or even a graphical schedule based on a CPM schedule. You'll have a time of it if you do. If you try to do that with takt, you will hit the mark most of the time. It is best practice to show the project takt plan on a single sheet, whether that be 11 by 17, 18 by 24, or 36 by 48, so that the plan can be quickly seen, understood, and acted upon by everyone on site. The best implementation of takt planning is when every foreman has a laminated copy with other postings of the plan showing up at the hoist, on floor lean boards, in the conference room, and in scheduling deliverables. If it can be shown and understood on one page, we can see as a group, know as a group, and act as a group. This ties well to the judoka principle, or what we call the see, stop, call, wait principle. As mentioned before, this principle relies on 6 steps. 1. Discover an abnormality. 2. Stop the process. 3. Call for help. 4. Wait for help. 5. Fix the immediate problem. And 6. Investigate and solve the root cause. We create environments where people and teams can see as a group, know as a group, and act as a group to see, stop, fix the problem, and prevent it in the future. We must see what winning looks like as we work and improve as a part of the work. And when we see the plan, we can see 3 types of flow. As we introduced earlier, we must be able to see and manage all 3 types of flow. So what are they? They are 1. Workflow, the flow of work within a sequence. 2. Trade or process flow. The flow of trades in a manner that they flow from one area to another. 3. Logistical, design, and procurement flow. The directional flow of trades from one area to another. In other systems like CPM, you can really only see workflow within the sequence. It is very difficult to see logistical flow and nearly impossible to see trade flow. So why is this important? In This is Lean, Nicholas Modig describes the need for flow efficiency and resource efficiency. Resource efficiency is focused on optimizing the resource or resources and attacking work to the resource. Flow efficiency is focused on the throughput of flow units through the system and attaches resources to the flow units. In construction, this is somewhat backwards because unlike manufacturing, the workers flow through stationary work areas. So, the way we get the product to the customer in the shortest amount of time with the highest level of quality is to actually flow the workers through the stationary areas in the best possible flow. Trade flow is flow efficiency in construction. The concepts of flow efficiency and resource efficiency can be difficult to translate into construction, but suffice it to say that we need both. In construction, we need the trades to flow from area to area in an efficient manner, and we need work within the areas to flow to the customer in the shortest duration of time with the highest level of quality possible. We have trades flowing and work flowing. The main object of the project team is to supply the workers the materials. That is why we bring materials just in time. With Takt, project teams and especially superintendents need to hold the dates and avoid the temptation to jockey the start dates of scopes forward and back randomly outside the collaborative plan of the project team with trade partners. Why is this so important? Because variation creates excess material inventory levels and disrupts the flow of all supply chains on site. When trades know the super will not follow the plan and will likely move out their start dates, by habit, the trade supers and foremen begin to increase material inventory levels to anticipate their whims. And every time inventory levels rise, so do worker counts and the costs to manage them. Only when a schedule is predictable can we bring materials just in time to supply the crews and support trade flow and workflow. And it only works when we hold the dates. Just-in-time deliveries really only work with Takt planning and really only work when project teams hold the rules of Takt by holding the dates. Now, there are some exceptions to this rule. If there is a major shift needed for project success that can be coordinated with all participating contractors on site, and that can be coordinated with procurement, then this type of change may be acceptable. But for the most part, gaining time in Takt planning is done in the plan analysis where we optimize throughput time and gain buffers by running simulations that determine the ideal project duration based on the number of Takt wagons, Takt areas, and Takt time. When a project is coming out of the ground, expediting or advancing the schedule is more appropriate because there are fewer contractors. Therefore, it is more acceptable in the early phases, but only under rare circumstances should dates be moved and start dates be adjusted when there are over 10 contractors on site working in rough-in, exteriors, or finishes. With Takt systems, we need to hold the line, keep the rhythm, and be disciplined. Otherwise, we leave the system and the project descends into chaos. Therefore, Takt planning requires project teams to hold others accountable, control the site, and hold the line. This is very difficult for a team and can be a reason project teams may be hesitant to use the Takt system. It is also why trades may be hesitant to participate with Takt because they will be held accountable. You can be sure that weak leaders and non-accountable trades will not like Takt. Takt keeps the system stable, and then the team can accelerate when we prefabricate as much as we can. Consistent and stable scheduling systems need to be supported by prefabrication. When a project is entirely stick-built, it will generally experience uncoordinated work issues with slow and unpredictable installation rates, which will not fully enable flow. To be as effective with Takt planning as we can be, we need to prefabricate as much as possible within the project budget. Prime examples of this are overhead MEP, head walls, corridor racks, exterior wall panels, and standard plumbing racks. It would be ideal to continue with that goal and add in concepts like underground MEP, room kitting, where we pre-cut and kit entire rooms, structural prefabrication, form prefabrication, pre-cut studs, header prefab, exterior cladding prefabrication, and finished assemblies. The vision for this is limitless, and the point is to move workers into a more stable environment, such as a shop where the production of assemblies is safer, more controlled, predictable, and there are better conditions for workers. Basically, following an assembly schedule is easier when you can piece it together like Legos or IKEA furniture. We must prefabricate as much as we can to create consistency and flow, and we prefabricate to the beat or rhythm of a production schedule, namely takt. Prefabrication also moves up the coordination process in the timeline of a project and assists in the general effort of removing roadblocks as our first priority. The prefabrication of drafting, detailing, and assembling scopes before they arrive on site will allow teams to discover issues earlier, which reduces waste. This will enable teams the time to focus on the pursuit of identifying and removing roadblocks everywhere in the system. By following traditional CPM, a superintendent's time is mainly spent managing the schedule and the chaos caused by not hosting remarkable meetings and communicating a stable plan. With takt, we have remarkable meetings according to the standard meeting schedule and builders who can focus on being builders in the absence of having to manage a complex schedule. Significant time is now spent on preventing interruptions, waste, and variation. Before, the time spent managing the schedule was at 60% of the day. Now it is at 5%, so the remaining 55% gain is focused on preparing the work, identifying roadblocks, and then removing roadblocks. The system can only be successful if the project team is committed to doing this, because there is little point in creating a stable scheduling environment if it is doomed to encounter a chaotic installation process. Ignored roadblocks bring the system to a halt. In takt, with knowledgeable builders, most or all roadblocks will be successfully cleared from the path in time using this system. This happens when we control geographical areas. The control of geographical areas, or takt zones, is one of the main benefits of using a takt system. Since most areas are broken out into standard areas based on standard space units, the standard flow of work through a building, according to the takt plan, itself to a great system of trade partners controlling their assigned areas for safety, cleanliness, organization, ownership of trade damage, roadblock removal, and a host of other things. In scheduling systems like CPM, the lack of consistency moves the responsibility of areas back to the general contractor because there's no clear identification of where and when trade partners will be working. This all changes with takt, and while it can be an abrupt culture shock for some contractors, it works very well. Where we have geographical or takt control, we have control of the project because supply lines, organization, and the safety of workers help productivity as much as quick hands at work. As trades help control areas, then we focus on throughput, not individual efficiency. The throughput through the entire system is our focus, not individual efficiencies for trades. We want collective efficiency for trades. We want trades going at relatively the same rate of production. Stated differently, we want everyone to succeed together as a group and to optimize the whole of the project, not just their individual companies. Listed in the definitions section, the throughput is defined as the rate at which a certain amount of material or items, or in this case the construction processes, pass through a system or process. The more efficient that this process is as it passes through the system, or in this situation the building, the better our throughput. Individual efficiency is concerned with the production or utilization of individual resources or contractors, which does not always help the overall throughput. In fact, it interrupts it. We need all contractors working at relatively the same throughput according to the takt time in order for there to be flow. If contractors are working faster or slower than average, it might seem helpful to that individual trade partner's productivity, but it interrupts the overall throughput, creates variation, and increases inventory levels, which increases defects, which, well, by now you get the idea. Little's Law. According to Modig, Little's Law states that the throughput time is equal to the number of flow units in the process multiplied by the cycle time. In translating this to construction, we can say that throughput time equals the number of areas needing a process multiplied by the process duration. So, throughput time equals number of areas needing a process completed in a phase multiplied by the process duration. For example, if the throughput time for the framer equals 10 areas multiplied by 5 days, it would result in 50 days. If the in-wall electrical roughing contractor has a throughput time that equals 10 areas times 10 days, it would result in 100 days. Let's now say that the remaining contractors all have throughput times of 50 like the framers. Plumbing in-wall rough-in equals 10 areas times 5 days equals 50 days. Insulation in-wall rough-in equals 10 areas times 5 days equals 50 days. That would mean we need to speed up the electrician. How do we do that? By adjusting resources to match the throughput times of the other trades. We need to get 2 crews, and the formula would be as follows. Throughput time equals 10 areas times 5 days with 2 crews equals 50 days. We now have a balanced system and are all going at the same rate together. What if the inspections at the end were added to this? Final wall inspection equals 10 areas times 2 days equals 20 days. The throughput time does not match. What do? We can either slow down the inspection process with a smaller crew, which is not possible in this example because there is 1 inspector, or add 3 days of buffer to the duration to even it out. Final wall inspection equals 10 areas times 3 buffer days and 2 working days, meaning 5 days, equals 50 days. The wall inspection will have starts and stops, but the entire system is moving together in one synchronous rhythm. These are the types of decisions we have to make to optimize the whole of the project, sometimes at the expense of individual contractor efficiencies. In some instances, we have to speed up certain resources and slow down others. This is called leveling out around bottlenecks as our strategy. Okay, everybody, we'll finish right there and we will continue. There's so much more with Takt Works When and Takt Works Because. And then we get on to the next section, which is good, better, and best. What does the industry do now? So we hope you're enjoying this content. I know some of it can seem just a little bit technical. Please stay with us. Once you get done with the end of the book, I promise you it'll all come together. So we appreciate you, and on we go.
Please join us next time in elevating the entire construction experience for workers, leaders, and companies coast to coast. If you're enjoying the show, please feel free to share with your construction colleagues and help us spread the word by rating, subscribing, and